Και το tooling γενικά που έχει ένα σύστημα, είναι πολύ σημαντικό. Πολύ ας πούμε πλέον είναι βασική το χέρι γύρω από μέσα. Και γι' αυτό εμείς τώρα φέρνουμε το χρηματικό και πάμε για τα. Γι' αυτό το φόβο σε αποτέλεσμα δύσκολα περιμένουμε ότι υπάρχει κάποια ταπερατήρια που θα έχει δεν υπάρχει sullo stage.
Okay.
Right. So hello, welcome everyone. It's very nice to see you all again. This is our fourth meetup. I'm really excited with the momentum we're gathering. This event today is very kindly sponsored and hosted entirely by KX Solutions. And my colleague here, Christos Hadjikomnitas, did I get it right?
Yeah.
Okay, is going to be talking to us about KDB Plus. Okay, so without further ado, I'll give you the floor.
Thank you. Thanks a lot, first of all, for hosting us and giving us the chance to present that totally unknown and new to almost everyone, I suppose, database and programming language. So, first of all, I'm working for the last 2.5 years for First Derivatives, who is the major stakeholder of KX now. And they provide consulting for KDB developers all over the world. The most important thing for KDB is that for the last 20 years, it holds the almost 80% of all the banking and trading systems all over the world. So almost 80% of all banking and trading systems are built with KDB, or at least assisting by KDB. So, first of all, why I am here, why you have to listen to me, and what you might earn from that meeting, from that meetup. First of all, I just talk about this totally unknown, or if someone knows anything about that language, I suppose no. Totally unknown language and database. We have an integration here between the programming language and the database, which is growing the last few years. And the final aim of the company is in the next 5 years to be also in many different domains, and not only in the finance, where it's already the leader. They are targeting the pharmaceuticals, they are targeting telecommunications, they are targeting the marketing market, and many other that we will see in the next few minutes. The second is to give some very basic information. I have tried to keep the presentation a bit low in technical level, because I suppose it's just an introduction for almost everyone, and because it's for a specific sector and a very specific language, I just wanted to give you an idea, and then during the discussion, during the questions, and even after that meetup, we can have follow-ups on that thing if anyone is interested. Third is to discuss and answer any questions that I can, and then wherever I'm not the best person to answer any specific question, I can just move that and keep any questions and direct to any specific person in our company or anyone that we know that can answer, or even give you the resources to find out what you're looking for. So, as I said, KX has dominated the capital markets for over 20 years. It was the beginning of '90s when Arthur Whitney, who was working with APL and A+, then at that point he was working for Morgan Stanley, and in Morgan Stanley was the very first company that they adopted KDB and started building systems. From that point to the current point, Morgan Stanley has made a huge improvement and development in KDB. They have adopted so many different plugins and different approaches to solve problems, both in analytics, in trading, in surveillance, and many other different topics inside the bank. So then, as we said, it is a combination. It is a database, a columnar database, but it is also a programming language. With a schema in our mind, we say that KDB is the database and Q is the language. That's why many times you will see in the slides that we refer to Q and KDB. They are exactly the same thing. When we are talking about KDB, we are talking about the database. When we are talking about Q, we are talking about the programming language, the commands that we can give to the database. Then, the strong points. It is a streaming real-time and can also handle a lot of historical data, which is very, very important for the banks. And that's why that was the reason why it's the leader in that specific domain. We have currently two different versions, one which is a 32-bit free for non-commercial use. That is, okay, you know how we can say that. And another one which is a 64-bit commercial use. This is this is totally used by the banks and some other companies the last few years, like communications or utilities companies. In Canada, for example, a water supplement company is using KDB to get from sensors different metrics and create after that specific targeting for the customers, allocate the resources, and move on to different other use cases. About the 32-bit, the 32-bit is available for everyone to download and play with it. It is very, very, very easy to download and start with it in just 5 minutes. We will see how it works on the terminal, which is very, very simple, and that's one of the strong points of this language compared to, let's say, some Hadoop installations. The other thing, it's really high scalable because imagine that the banks get every single day more and more and more data for all these years, and they still extend the data sets that they are analyzing and they are working on, and we still are in a very good level of processing everything. And the last thing is what I said, it's the ability to process and react by applying different functions to billions of ticks per second. So some numbers by KX. It can handle 3 million single inserts, updates, joins, and selects per second. It can handle 20 million bulk inserts, updates, joins per second. And in total, it can scan the whole database for 300 million records per second in memory. Because after that, we move to the disk. I'll show you a diagram and explain what we are talking about in memory. Then it supports thousands of concurrent queries involving billions of rows of data. We'll see some examples only in the terminal. It can integrate and coexist with different other technologies. For example, there is a technology used by CERN, which is 0MQ. Probably some people here might have heard that. It is a messaging queue, let's say. This has been used by several banks in integration with KDB and many other different. I'm not talking about the languages because it's obvious that it can talk with and connect with almost every single well-known programming language and the databases. It requires minimal infrastructure to fulfill performance and data volume requirements. For example, this laptop is enough to do something very specific and with low expectations, but have a good result. So you don't really need huge amount of memory or servers or anything. But when we are talking about the banking sector, then you understand that these numbers about RAM, for example, or disk or CPU are going to a different level. It's not about single machines. Then it is very cost effective in terms of scalability and it doesn't really have to be changed and a lot and have many configurations after that. So it's easy to apply any new parts and migrate, let's say, some parts to be scalable. And the last one, yeah, we talked about, we'll see some benchmarks at the end of that section. Then you're the big data, so you know even better than me that specific thing. When we are talking about the big data, we are talking about the 3V, the variety, the velocity, and the volume. Until now, the KDB was very, very good, maybe one of the best, on the 2V, which is the velocity and the data volume, because the kind of data that it was handling in the banks had these two specific, let's say, cases. It had a lot of, a huge amount of data coming, the volume was huge, and also it needed a huge velocity, as all the data must be parsed in just milliseconds or nanoseconds. But until now, the variety was not the first priority. This is changing the last 2-3 years, I can say, as it is a very important target for the company that handles KDB and also for all the developers to try and move KDB also to different domains. So it is very important for them that the database will be able to handle different kind of data and not only financial and not only time series. That's why we say that their aim is to go also for the third V. So, as I said, the language and the database started from Morgan Stanley, but in the next few years until now, almost every single bank has been using KDB for most of their really critical and important systems that need to be up to date with every single ticket that is coming from either Reuters or Bloomberg or any other data feed. We'll see the infrastructure, a general model of the infrastructure, like how the whole schema of the setup is looked like. Then another important thing for this language is that not only in the banks they use that. In the last few years, and especially after the crisis of 2008 and all the coming years after that, it was very, very important for all the regulators and the exchanges to make sure that every single record, every single exchange that is happening is correct. There are no black holes, and the whole system is working correctly. So a way to do that was many of that exchanges. For example, the Australian one used KDB to build up a surveillance system, which is monitoring the whole records coming in through the day, and at the end of the day and during the day, intraday, providing some reports on whether a specific record is suspicious and whether some more checks need to be applied on specific records of what has traded. That's the kind of things that have happened. Also, there is a term used the last few years for black pools. The black pools were an idea that was used by the major investment banks to have some trades during the day, but have those trades outside of the official exchanges, and so have those trades outside of the regulators. So that's why they were called black pools, because everything there was like in the dark. You couldn't see who is trading and what is trading and in what volume. You couldn't see the speculation on that, so you couldn't really affect anything if you were the regulator, for example. So even that systems had built up using the KDB because it helped them to move very fast with all these kind of trades outside of the exchanges, and also the regulator side that after some years tried to catch these black pools and put some, let's say, limits on that and find out what is happening, also used KDB for that. So it's a kind of chase one after the other. So why is it the fastest, and why the banks use it because it is the fastest? First of all, it automatically distributes the database operations across all the cores, across all the CPU cores, and that helps a lot. This is done also programmatically, like you can use specific functions already built in to create as many slaves, for example, as you need, and that can all be modified by you in your code. Then we have what I was talking about earlier, that they have a very good cooperation with Intel the last few years, and they are trying to exploit the latest instruction sets with that collaboration, let's say. It has a very small memory footprint, and we'll see also how small the installation of KDB is. I'll show you my laptop. It uses the GPUs to offload the processing cycles from the CPUs, and also uses some other different tricks, which are the slaves, the HTTPs, which we'll see in the diagram for the schema of the total setup, and a term which is called enumeration, which is used in the financial, as it works very, very well, because it is focused on the column of the instruments. For example, for the stocks of Apple, of Google, of anything. So we have an enumeration on that specific column that makes the whole database to be much, much faster. This is the last 2 years and the future. So they are trying to extend the usage of KDB to pharma, to energy, to utilities, and defense and telecommunications. And I have to add the Internet of Things, which is, I would say, the most important on this extension that they are trying, because the Internet of Things works exactly like the financial system. It always gets new measurements. It works like the finance world. We always get, like from Reuters and Bloomberg, specific ticks for a stock. It is exactly the same thing. We would get always specific ticks, let's say from thermal or for the water, about anything. So we have new ticks and we have new data, and we need to process that, make some analysis, whatever the application has to do. On energy, and more specifically on oil and gas, almost all the big oil and gas companies like BP, Total, are also, they have specific development teams which are using KDB in order to analyze all of the data from the locations that they have the extractions, and even for the marketing. Then some details to put about the Q programming language. As we said, KDB is database, Q is a programming language, and about the programming language, Q is interpreted, it is functional, so we are talking about functional programming, and that's why we said that the root behind that was APL and A+ in the past. It is array and vector based. It looks like SQL, the query syntax. We'll see some of them, and you will see how similar it is. And the good point is it's very concise and expressive, and it is easy to learn. that's we'll see how easy to learn it is in the next few points. That's what you see when you open a terminal, a cube and the bracket, and just waits for you. So I don't know how well you will see that, but I will do that also on my terminal after we finish, so don't worry even if you don't see. What I'm doing that here is opening a terminal, running cube, adding some numbers, getting back results, very simple things, making a division which is not right because I used a wrong symbol, and that's a point that I wanted to explain to you about how easy to learn it is. Until, let's say, 1 or 2 years, it was very hard to explain the errors you were getting. For example, when I used the slash for the division, I got backtick and the slash. This could be clear, but in any occasion, you don't get exactly what's your error, what you have done wrong. So what they are doing now is trying to create an ID, and this is done. There is a development team in which the head of it is the guy that worked for IBM to create the Eclipse ID many years ago when the visual work was not with us. So now they are trying to make an ID for KDB, which would be very easy for all of us. And when we get simple things, simple errors like that, we know where we should look for and what we are looking for to change, and more things that we will see. That was a very, very simple thing. We will see again in the terminal more details. Here we have the very simple arithmetics, and you can see that it's nothing very strange. One thing you might need to pay attention is, as we are talking about functional programming, actually many years ago when I was studying at my technological educational institution, we had a lambda calculus course. And by that time, even though I was good at it and I liked it, I couldn't really understand what's the point of having that course. After many years, when I reached that level, I understood that here we use the lambda calculus. For example, as you can see in the third, fourth, and fifth example here, you can see that the symbol in each of those cases is applied either to the pairs and the monadic in the first case, where we have 22 minus 10 and 33 minus 10, and the same for the rest of the things. That's why we say that it's under the umbrella of the functional programming in general. Then it has many built-in functions which are very useful when you know them and you know how to use them. And for example, here you can get rid of many loops as we use in all the traditional programming languages like Java, C, C++. So here you just have a list which holds all the instruments, all the numbers in that example, and then you apply on it the function, the max, the reverse, the average, and the mean, and you just get back a result. All these are built in, nothing to invent from scratch or work on that. So now we go to the queries. As we said, it's very similar to the SQL. So as you can see here, we have a raw trade table which holds some symbols of stocks, for example, some prices, and some size, like the volumes, how many traded. And the query that we want is to get from that table all the records, but the symbol is JVM. So you can see that the result is coming only a small table where the symbol is only JVM, and it's exactly the same like SQL, nothing different. The difference is how fast this is done. Next example, you select the symbol from the same table, you name a column as high, and in that high column, you just assign the maximum of the prices from that table, where again the symbol is JPM. Here you are doing an extension of that. You create a new column which is called open. You get the first price for each symbol, and you can see that we are talking about each symbol where we use buy sim from trade. So it's kind of organizing the database by each symbol, and it's getting the opening price for all of these different sections. And again, we have the high, and it gets the maximum price, the low, it gets the minimum price, and also we have the close, and it gets the last price. As you can understand, first, max, min, last are all again built in. That's just let's say, a comparison of Q and SQL, just to show how little you need to write down to get the same result for one and the other. But we'll see in a join in KDB later from my terminal, and there it might be easier to get that point. So the data types, we have all those data types, and you can see the character that is used internally in the language. You can see the size of each of those data types. You can see the number that is used again internally and the literal of that. And we have also a null, because in KDB, wherever you have a null field, this field will not be just a null in general, will either be a null timestamp, if the whole column is a timestamp, will be a null integer, if the whole column is an integer. So we have a division between each of those nulls. It's not every single null in one same pool. That's a big difference, I think, compared to many other languages and databases. What else we can point from here? You can see that the timestamp, time span, and in general, the different usages of date, time, take a lot in that data types, because it was very, very important for the financial institutions to have very, very specific data types for those kind of columns. It was one of the most important values in their tables after the real values, the prices. Yeah, that's all. You can see that the size of the global unique ID is the biggest one, and all the rest have smaller size. Yeah, here, just where you can find more details about KDB, because some years ago, only a few people being inside the financial sector had some idea about where to look for KDB. In general, there are only 2 books in the market, 2 books all these years. So you can imagine how difficult it is to get some idea. And there was also the website, codekex.com, that you can find every single reference and most of the things. By the way, at the end of the night, whoever wants will come to me and we'll put down some names, and we'll have a lottery for one of those books for one of you. Also, in the documentation in the CodeKX meetup, in the CodeKX.com, you can find everything like these data types that we saw earlier, and every single point similar to that, from very technical things to more high level, like how you can set up, let's say, your databases depending on the size of the database. For example, in KDB, we divide the tables that we use, the databases, depending on the size. That means that if we have a small amount of records, which could be, let's say, 50 million, that's small, you can just use a single large file and scan everything in once. If you go to much higher numbers, like billions of records, then KDB uses different transformations like partitioned databases and splayed databases, which are all explained inside, and they are helping a lot in making the whole process much faster, even though you have billions of records. And also has inside the site, we'll see the site together, some tutorials, so you can go step by step, and it has some, for example, workshops, things like that, that you can go step by step. Not very difficult. As soon as you have KDB installed, then most of the things are very, very easy. You just need to have most of the things inside your directory. We'll see how a directory of Q looks like here, just after we finish the presentation. Here, again, about the strengths and what is unique, or what is some kind of unique. First of all, it is a very fast and extended SQL. We saw that it looks very much like SQL, almost the same way of writing your queries for select and for update and for delete and for everything. And it can be used in any position function. Then you have that the highest usage of that language is the time series. That's the best area, the best domain that you can apply that specific database. So then, if you are trying, for example, to use the database for different kinds of data, either you can use the plugins for the other languages and connect them with KDB, which makes that much, much faster. For example, last year, they had a very big collaboration with MongoDB in order to make an integration between the two languages and use all the good points of Mongo, which is not obviously the performance, but it's a good schema for documents that it has, and use that totally different schema and installation to pass the data in KDB, and then use the performance, which is the strong point of this language. So the point is to use the strongest thing from whatever you have around. Q is a live interactive vector functional language, so you can write your functions which can do anything. It's not just writing queries for SQL, like SQL. You can create your functions, and one advice is, if a function is more than 3 lines, then you need to divide it into more functions. We have applications that execute the store not through ODBC or JDBC, and we also have many cases, like in the bank that I'm working now. Almost everything is in a combination of states. Most of the instruments are inside JDBC and then passed into KDB for processing, for analyzing, and then back. So it works vice versa to do the job, because it might be cheaper to have a normal database and then pass everything for analyzing to KDB. Then we have a lot of the plugins, as I said, for almost every single language. And one important thing is the IPC, which is built in the language, which is a process that allows you to have a connection between client and server. So you can even set up on your machine connection between client and server. For example, having in one terminal your server running and having inside all the database, and then in another terminal running the client session and retrieve from there specific queries. You can also put limits and to the access. For example, in your terminal that you're running as a client, you can have limits to what you can get access to and what queries you can fire. And all these are built in that. And what else? A very important thing is the simple map reduce via bits. Bits is one of the most important and useful functions of the language that is used to allocate to the different cores all the processes. So it's used like dividing the process to many different cores. And the last thing, supports the high performance by using the RDB and the HDB schema that we will see now in the next one, I think. First, I'll just tell you which is the focus now and what they are trying to do now. The most important thing is to finish with that IDE that is a huge help for anyone working with KDB. Developers, administrators, DevOps, analysts, project managers, even simple users. It will be much easier to have an IDE that gives you the idea and doing simple tasks that each of those categories that I mentioned need to perform. And of course, the focus is to make it even better on the time series databases, which is done through this collaboration with Intel. In the next few years, the performance will be even better every single year. And another very important point is to create the dashboards and the visualization, because that was one thing that the language was slightly backwards. It was using a lot R to create some diagrams. It was using some JavaScript, but there wasn't a standard library, let's say, to use for everything. Now it's starting to become more specific, more organized. So that will be even better in the next few years. So you can combine JavaScript, HTML5, which is used a lot, and any other tool to create your visualization, to create your dashboards, which is very important in different environments, so you see what you are doing. Now, that KDB tick is called the setup. So KDB tick is used to capture, store, and analyze massive volumes of data in real time. This is the setup that banks are using to get the data from data feeds like Bloomberg, like Reuters, in real time, and process that data and store that data. So a standard KDB tick setup consists of a ticker plant, a real-time database, RDB, as we say, and HDB, historical database. And what they are used for. The RDB, first of all, the RDB is used to store the current day's data in memory, which is the strongest point of the language, because when you have something in memory, you can process that many times faster, and write it at the end of the day with a specific process, which is called end of day, to the historical database. The historical database now has access to all the data prior to current day. So you have a huge database, which is called HDB, and that database holds every single data from yesterday and back. You have the RDB, which holds all the data from today in the morning, let's say in the exchange in Athens, until the end of the day. At the end of the day, we have a process that kicks off and takes everything from the RDB, moves everything in the HDB by creating a new directory, and then clearing, deleting everything from RDB. And what is ticker plant used for? It is used as a medium level, let's say, a middleware between the feeds from Bloomberg, Reuters, whatever, to the RDB. So it captures and logs all the incoming data. So in case something happens, a failure, an outage, whatever, we still have a specific file, which is called a log file, and has all the data that we had during that day. And if something happens, then it can go and replay that data. So we send everything again to the RDB, and we are back to normal in just a few minutes or hours, depending on the volume. About the minimum that we say here, it is recommended to have RAM of at least 4 times expected data size. So for 5 gigabytes data per day, the RDB should have at least 20 gigabytes RAM. In practice, much larger RAM might be used, but these numbers obviously are for the bank sector, not for a normal, even for a startup system, couldn't be that huge. Then, again, about the ticket plant, just a few more things. It writes all incoming records to a log file, as we said, to replay in case something happens. It pushes all data to the RDB. And also, if you have, let's say in your system, you have the standard installation, the RDB, the HDB, and the ticket plant, but you also might need to create some specific processes that take some of the data, not the whole data intraday, take, let's say, some very specific sub-data sets and process them totally in a different way than the RDB, let's say for a totally different department or anything in your company. This process will also go to the ticket plant, get the data, not to the RDB, and that again happens in order the RDB works without any issues during the day and to get rid of any chances of having any outage or failure. So here what I described. So as you can see in the orange, we have the data that's coming through the feeds. It is going to the events engine, and then we have the streaming queries. So we have the data coming into the events engine, which can be assumed to be the ticket plant, and then it's passed inside the RDB, which you see it's in memory. Everything in orange is in memory, and then the gray part is the on disk. So as you can see, the HDB is always on disk, and that's why we can store that huge amount of data, which are for the past days. And then you can see also the log file, which is pushed from the ticket plant, and the HDB at the end of the day, where the RDB pushes everything. You can also see that we have some interaction between some applications and APIs. There are many APIs and different applications which are not using KDB, which don't have any single connection with KDB, that just connect through some sockets or different ways and the APIs, and getting data, subscribe and publish in our architecture, and also they can query the database and get results. This is usually done by using the gateways and the UIs. We'll see that. And as you see also, there is a in database analysis just under the log file. That's the place where most applications go and check the data that is outside the RDB. That's the gateway point that I mentioned just a second ago. So it is the entry point for all the external applications and the APIs, and for all queries that we have. This is used to allocate better the resources. So in the project that I was working, we had a cloud, let's say, schema where many queries were coming. They were putting inside a cloud infrastructure, and then from that cloud they were pushed to different servers that all of them could process the same amount of queries and give back the results. That was done with different network protocols. That's another thing that you can use. For example, some plugins with different network protocols that can also help to have faster processing. That's most of the times done through closed plugins, where companies sell that to very specific companies like banks. It's not something very cheap for daily use. One important thing is the asynchronous calls that we have to the RDB and the HTTP, which are aggregated in the gateways. So we don't have the danger of getting too much calls in the RDB and the HTTP, which are the most valuable points in our ecosystem. And also, the asynchronous calls allows several requests to be processed in a different time simultaneously, and it implements a load balancing where we have, because in a system we might have more than one RDB and more than one HTTP, so it allocates that resources so that it hits the ones that don't have that much, they are not that busy. Now, about the real data, the big data, and how the KDB is compared with the, let's say, the Apache Hadoop ecosystem. So, the thing about the big data is that we have small sensors that send huge amounts of terabytes, petabytes. We have streams that pass data. We have a semic structure. We have mixed media, which KDB is not yet very good. And in case you need to use KDB, for example, for let's say videos analysis, then you need to use currently some C or C++ plugins and then work with it. That's the point that we were talking earlier about the variety of the data that it can handle. That's different now. It's getting better with every single kind, but that's not the best point. We have again the missing data many times, the dirty data, and in general, probably you all know from the big data much better than me all the danger locations that we have to check for the data and how clean it is and how valuable it can be at the end. So now, the open source Apache solutions. And when it started in 2008, there were 4 open source projects in the Hadoop stack, in the whole ecosystem. And that had a big complexity by that years, almost. In the next few years, more and more people were getting involved with that, and they got a very good knowledge and working with that. But still, the need is for very good Java programmers, and for every single project, very good knowledge on something really specific. That's now 22 open source projects. That means that we have people knowing very well one of these 22 projects, or even some more of those 22 projects, but this is still counting. So more and more projects are coming up to support that. Even though, for example, Cloudera announced that the Hadoop will go back and the Spark will be the leader of that side. Even though we have some of those projects going back one step, we still have a lot of projects coming up to support this specific area, the specific domain. You can see here many of those projects, and the question is for a company, not for us personally, for a company, what is the total cost of having open source freedom on that specific area? Like, you have some employees which are who are working on some specific, let's say, Spark, some other projects, and based on the nature of the data, based on the nature of the demands, what you need to do, you need to work also on different projects. That makes you have always the need for people to adopt to new projects and new technologies. That needs very good Java programmers, wizards to install, configure, integrate, build the pipelines, develop, and query. That causes a lot of problems in the banks that I know, but more probably to most of the big data companies that need that kind of processing in the big data. Here, the Apache stack is constantly growing and changing. It requires expensive specialized big data Java or Scala experts to configure, integrate, and build, develop everything. It has some vendors who offer their own similar but different distributions. That's the truth for every single product that you have outside. It makes it very difficult to stay current, up to date, easy to get left behind on legacy installation, and the multiple schema and the storage formats for many different projects is a problem. Then we have many specialized query languages and tools which are alternatives like Peak and other projects, which are doing more or less same thing, but in a different way. And each of them has some very good points, some drawbacks, but in general, they have the same aim at the end. And the solution often have less capable or performance. Like HyperSQL offers less functionality and lower performance than competitive SQL. The HDFS requires roughly 3 times the amount of storage, and the other points that we have listed here. That doesn't mean that these projects are not good and don't help the companies. Many companies and many projects all over the years from 2008 and after made a huge progress using the HDFS system, the Hadoop, and the whole ecosystem. But what we found from specific queries, and especially from banking queries, is that the whole adoption of the Hadoop ecosystem compared to the KDB is not doing that well in cost terms and in performance terms. And that's why we have those points. That doesn't mean, again, that it's not useful for researchers, for even other companies might find it more useful or get better results. And one other thing is that every single year the results and the measurements are getting better and better. So this was, at some point, we'll have some benchmarks. I think it's in one of the next. We have some benchmarks which show for some queries, I think they had 4 queries in the labs, that they used 4 queries that banks usually run, and they use some different technologies of databases. You will see at that point where they have the difference. So here, the KDB stack compared to the Apache. Everything you need is a single suite which can be installed in minutes. That's true. It's very easy to install. It's a matter of some minutes only. You can upgrade easily to full support, but cost effective. This changes also because until now there were only banks that used KDB. So the cost was relevant to the sector and what you need to do there. Now that we have some startups using KDB. We have some other companies like utilities or other areas. They start to adopt different policy, but the best place to ask for that is the sales department or anything with KX. But the support they offer for that is very good and for anything. For the normal users, still the 32-bit is excellent, doing the job, and the community also can help a lot with different problems, solving problems. There is a Google group for everything. There is a mailing list that answers everything, and even actually most of the mails are answered by the two guys that have written the two books that I mentioned. So you can really trust the quality of the answers. So it's a very good place to go and ask. Then we have real-time streaming and batch processing. The real-time streaming, I think it's the strongest point to emphasize on that. And the batch processing. Then we have the reliability and performance, because when the 80% of the banks used for the last 20, 25 years this specific language, the expectations from the language were very, very high, and every single moment it was tested. They still use it, and they try to put it in even more and more applications and domains. Like some years ago, it was only on trading. Now it's everywhere in analytics, and it's going inside many other locations. And they are trying to get rid of different applications that are slower and more difficult to scale and adapt to different applications or APIs. Yeah, that's the most important point. I can then send you, I've also sent to Miguel the PDF, but I can send the PDF if you want to see more of the points in detail. That's the benchmarks that I talked about. So in the labs, they had 4 queries provided by the clients, the banks, some of the banks. The most, let's say, the usual queries that they need to run, and they compare that with the big 3 RDBMS, the Postgres, for example, the Impala, the MongoDB, the Spark, and other databases, and they got some results. You might say that it's not very fair to compare the MongoDB with the KDB. This is very, very true. But the point is just to show that it is the faster, so you keep the best points from that fast language, and whatever is useful from the MongoDB, for example, you then pass it inside that language. But that's the point, to see that performance is the best thing that you can get from that language. Then, how these are measured in a permanent time and not by, let's say, our company's labs. There is a Stack company, which is based in New York, and this is an independent body responsible for quantifying high-performance solutions for trading technologies. So they publish every few months, every few weeks, specific research on different hardwares and usages of databases and other solutions, and so the results. On all those results, like you can see that for KDB Plus 3.1, this is the version. It holds records for 7 out of 17 tests in the category M3. That's the tick data analysis. Again, we are talking about the finance where the tick data is the most important. So that's a very good location to see that, yes, it's true, it's the fastest on that specific part. Then the academic use, maybe we have some students, or yeah, we have some professors or anything. We have many universities, you can see some here, like the ETH in Zurich, or the Goethe, or the MIT, that they use KDB licenses for academic usage. There exists a different license for academic use, and that can be changed very easily by communicating with the company, and they use that mainly for their financial engineering programs. That's the most usual course, but also for statistics, where they combine that with R or other languages, and MATLAB, where we also have a plugin to communicate between MATLAB and KDB. And in many other programs, like for mathematics, they have a lot of different courses that they use KDB Plus. That's very general slide about the functional programming and why the adoption of the data-intensive computing is coming to the point that we will need to use more functional programming on the data, applied on the data. But yeah, it's all the different points and some of the functional programming languages that you can see are well applied on those points. And here, again, Q is easier to learn than Scala, F#, Haskell, and Clojure. Left or right execution takes some practice. It says the start, and error messages are too cryptic. That's the error message that I mentioned earlier. In the next few years, it will probably be totally solved with the IID, with the IDE. And about the left to right execution, yeah, in the beginning, like it took me some weeks to be totally used to that. But after some point, you really get to the point to understand how it works. So it's not that difficult. And what else we have here? It provides the most efficient execution and serialization. It's very expressive and concise. You saw some queries, but not enough. We'll see some queries, and especially a join of two tables that you will see why we say it's so expressive and concise. It provides a fully interactive read and write and everything for scripting. It's it's easily integrated with other tools. Like you can use it with different IDEs that exist now, but don't have that many, let's say, functions that you can use on your daily life, your daily programming life. And Q, at the end, is the only functional language to embrace and extend SQL, which provides an easy path for query to the functional programming. So it's like a bridge between the functional programming and the easy life of SQL. It provides a data language that runs inside the database. It has a term as a native type, what I told you earlier, where in the data type table we had a lot of records only for timestamps and data type and dates. It provides nulls and positive and negative infinities for all types. Yeah, the two infinities I didn't mention, positive and negative, are also one point of the language. But the most important is these nulls that I said, that for each different type, you have a different type of null. Not everything is just one basket in one pool. So, one more thing, it provides persistent unbounded lists, dictionaries, and tables. These are the three most important structures inside the language. From a list, you can create a dictionary. From a dictionary, you can create, not from one, from many dictionaries, you can create a table. So this is how it works. You have some atoms, which are single, let's say, numbers. The single numbers make a list will make then the dictionary, and the dictionary will make the table. All these can be found in the sources that I will give you later, and whatever we can discuss. That's about the future. That's about the ID they are trying to make. These are some points that they want to make better for people, not for the language. So it's easier to adapt and to use. So they are trying to democratize, let's say, the access to the data, make it easier. and they want to keep the fast character of the language, but also have a good ID for everyone. They want to have HTML5 dashboards, so you can see what you're doing, you can see what data you get, you can see what data you're processing every single second. You have a visual loading ETL query, which is very important to see the schemas and the structures of your whole system. Then you have a visual explorer to take files, import files, and everything. A big data spreadsheet, which looks like very much with the Google Excel version. It has some unstructured text analyzer, which is getting more and more important, where in the last few years with Twitter and every single tool, we are looking more for unstructured data in text analytics. So it's getting an idea of that inside the IDE, so you can search inside many different tables or many different XML files, different documents. And the great graphics, again, it's a combination of JavaScript, HTML5, and different things. That's exactly the point where I mentioned where they aim, what they aim to fix for each of the different kind of users. Like you have the consumers, which are let's say the traders, for example, who do not have any single idea about programming or anything. They just sit on their machines and make trades. For analysts, developers, for DevOps, and the other components. For example, let's pick up the DevOps category. So there you will have in that tool, what you will have is integrated DevOps environment. You have the workflow on the whole process. You will get alerts and monitorings, things like Zabbix, for example, on the servers. Maybe some of you have heard. Like you get what is happening for every single process and the whole box. And from another category, for example, like the developers, you can have the IDE, obviously. You have a code editor, which is directly in connection with the heart of the database, so you can see everything running the same moment. You have a debugger, which is very important, and you will get rid of those errors that you don't really know what they are. Yeah, that's only some an idea of how it looks like when they are looking into data for Internet of Things. But as I said, the Internet of Things idea is exactly the same as finance. As you get the things, you have the similarity is almost perfect, because you have, let's say, the data you get from the temperature, which are like the data you get for one specific instrument stock for Apple. So it will be exactly the same, the timestamp and what measurements you get. It will be absolutely the same processing, and that's why I say that this area, the Internet of Things, will be very easily applied into the KDB. That's a usage in the telecommunications. So what they do is they are looking in the network and the system statistics, and that helps them detect any anomalies in the whole network and the infrastructure. They can make a balancing in their resources, which is very important, cost and also infrastructure, everything in the company, and capacity planning, especially for telecommunications. And they can also check the latency monitoring and some historical analysis. That's a very specific example for telecommunications where they do targeted marketing. So depending on what communications there are in a specific city, the age, let's say, of the people that are talking, the time that they are contacting each another, their movements around the city or different cities, they can use all these things, and they are using all these things to make different pricing policy and apply that to different sites inside the company. That's probably the most important, the most useful thing for, the most interesting thing for anyone that is for machine learning or things like that. That's a white paper that was published last September, and you can find there a connection between neural networks and KDB. It's very nice, it's almost 20 pages, and explains well with some examples from the beginning, not very hard. You can see and understand everything, and go ahead. This is my mail if you need anything, and or any questions that I can answer or I can send to someone to answer better. That's the wiki where you can find almost everything, and that's the best source that you can check for information, KDB, for something very, very simple, like how we start KDB, how we install, up to the advanced things. There is the KX community, which is getting better the last few months. More and more people are getting in and answer questions. They are helping. They are writing about new projects. It's an active discussion. There is a Google group and a mail list that you can also use. And also, there is a GitHub page that KX and other companies or independent developers from banks, but in their free time or outside banks, they have published some of their projects that are working with different kind of datasets. I think that's all. Before we finish, let me just show you an example. So, first of all, how it looks like. That's the Q directory. So everything for KDB is inside that directory. Then we go inside the DB tag. So this is how a database looks like. So you can see that for every single day, we have one directory. And inside each of the days, we have one of the tables of the database. So our TAC database has three tables: the MBBO, the quote, and the trade. If we go for the 4th of January in the trade table, you can see that these are the names of the columns. So as you understand, the file system has the names of the columns as specific files, and under each of the files, it stores all the data for that specific column. And now let's go to see the demo quick one, not something very difficult. So that's how we start Q, just by typing Q. You can see. Better? Yes. So these are Q. That's the Q console, and you can write there anything. So now, first of all, we'll load inside our session this database. So as you see, what I do is a /L, which is for loading, and I use the database directory with the name of the database. By using that, now in our session, we have loaded inside the whole database. So if I do, for example, tables, you see we get back the names of all tables existing inside the database. And you can see that because except those three tables, the MBBO, the quote, and the trade, that we have split it, divided for each of the days, because these are the important tables, we have some table files here, very, very small, and that's why they are not divided. And you can see them also being here in that list. If we try to do the following, like get the 5 first records from table 8. Sorry, what? Second. Again, load. Okay, we get the whole table, and as you see the dots at the end, that means it goes on. So this is how it looks like the trade table. So you have the date, you have the symbol, the time, price, size, the stop, the condition, and the exchange. So now I have recorded here some functions to do it much faster. So if you do a count trade, you just get the total count of the records in that day. That can move and run in every single table, and you can see the number. So it's again built-in functions. To go and let's do that, for example. So what I did there is asking for all the data that has as symbol the AMD. You see the backtick before the symbol. This is used on all symbol data types. And what we are asking for is having the last date. Another thing you can do is measure the time that the query takes. For example, so if you do /t and then your query, you get back the time of that. That definitely depends on your RAM and your machine and what else is running on it and everything.
What is the unit?
Yes.
What is the unit?
The
Millisecond.
millisecond, yeah. And you can also use, there's another command that gives you also the footprint of the memory for that specific query. And another thing you can do is, because sometimes it's very, very small, you can, I don't run it now, but you can use T and quotes and semicolon with a number to do it that amount of times. So you run a proper test for a specific query and you get real results. And let's try now something different. Let's try this one. So we'll do that. We'll see what's inside T. So as you can see, what we did is creating a table where we have the symbol, and after that, having all the close prices. And what we will do now is getting only the prices for that symbol, the HPQ, and then we'll run that command, which gives back the correlation between these two symbols. And again, core is a built-in function. So by doing that, you just get back the correlation between the HPQ symbol and the Oracle one for all those values that you stored in that table.
The time shift correlation?
Yes. You just need to use, I think you need to use a different enumeration on the time for that. It depends again on the table. But you can also find the correlation for a specific time.
No, I mean, you correlate HPQ with a delay of Oracle of 1 day. Or
Yes.
5 minutes. So you have
So to do it for the whole day.
Yeah, for the whole day, but with a different design in 5 minutes or something like that.
That should be in the function.
Oh, so you have to build a.
Yes, that's why we said that the language provides you with the idea of your functions, and that's why you can handle these kind of queries. So you get that one, which is built in and easy to get that, and then you can apply your functions.
So the default is the correlation on the data.
Yes.
From daily data.
Yeah. And another example, that's a join. So you can see how many characters is the join in KDB and how many lines is a join in SQL, for example, to join those two tables. So what we do here, actually, no, I didn't do that correct. I need to assign, first of all, the tables. So what we do here is taking from the two different tables, the trade and the quote, everything for the last date and the symbol IBM. So we first do that for the trade table, then we do that for the quote table. So if you do T, you get that. If you do Q, you get that. And at the end, what you want to do is to join those two tables based on the time. So you can see how the join command, that it's not very easy to explain how it works, because this is an as-of join. There are many different kinds of joins for KDB. You can also find them in the reference according to what you need to join, what kind of tables, and what specific fields from each of the tables. So for that table, for example, with an as-of join, you just joined the trades result with the quotes result based on the time. So you first give what you want to use as the base, the time, and then the two tables that you are trying to join. What else I can show you here from the terminal? Basically, that's an introduction. Maybe I said a lot more. So, any questions? Anything you?
So is there a roadmap for the IDE when it's expected to be released?
It should be. It's already in testing phase in many institutions, and I know that during the year, at some point, the IDE will be released. But currently, if you still want an IDE, there are many that are used. Like if you look in Google, there is a KDB Studio, which is also doing the job, but you don't have that high functions for everything. If you want just to connect, run some functions for KDB, run some queries, create your database, play with your tables, and find out what's happening with KDB, it's totally fine. That's what I was using during my first year. It's totally fine. This IDE will be something more about the whole approach of KDB, like for every single instance, as we saw for DevOps, for developers, for administrators, for everyone. But still, the IDEs are okay for a simple user.
Just to get a feel of the interface and capabilities, if you want to get some quotes, let's say from a I don't know, web API, REST API, how would you do that? Would you have to go to a third-party language, or can you do this directly from Q?
Inside the website, inside the reference of the Code.js, there is a whole list of all the plugins for languages and many of those APIs that are provided directly, so you can just use them and connect with everything. so no need to develop something additional. Then that's for the most common ones. If you go for a solution that is not that well known or it's very, very specific, then you might need to work a bit on that, or maybe someone already has something. That's why the community is working well. There are many questions about has anyone worked on that, and some old developers give some example or provide some code that they had stored for years, and that works well. But for most of the languages and most of the databases and many APIs, especially the ones that they are working in the banks, like REST, it's totally fine. There are many sources. There is everywhere. So you can find directly what you need, and no need to play hard with your customized solutions.
Thank you.
So I want to ask a little bit about, can you tell us a little bit more about plugins, right? So if I, just to give me a sense, so for example, in R, you would have a lot of functions, you would have a lot of plugins that you can get basically through libraries that you can download, and they would work for particular sort of areas of interest. So if I'm doing something like neural networks or support vector machines, I get a library for that.
Mm-hmm.
Is there a similar kind of logic here? Is that how you would work with neural nets, for example, in the paper that you mentioned? That it imports a bunch of functions and capabilities directly in this language? Is that how that works?
Yes, that is one of the approaches. In general, like for R is basically used, for example, in my bank, it's basically used by the FX department in London. So all the traders know how to use, how to develop, how to play with R. It's very, very hard and pointless.
My students should listen to this, by the way.
Yeah, it's very, very hard and pointless to ask from those people. You can't even ask from them to learn something new for KDB. So what you do is letting them use the R that they know very well, and it's a great tool for statistics and their stuff. And on your side, just get everything in KDB, process everything, because the processing on KDB side would have much different functions rather than the front side for the traders. And that's why it's better to use for their cases the statistics side, and for our cases just the processing side, the calculating. But about the neural networks, for example, it's not at that high level, because for R, the research and the development for that kind of cases have been for many years, right? Yeah. So for KDB, it's not that high at that level. There are people that are working with that and are doing some research on that. But in general, since KDB was not that much involved in PhDs, for example, where R was one of the basic tools and the most important tools in all statistics programs, you can't really expect to find many different cases like this neural network. But there are a lot of, basic approaches on that kind of problems and solutions. And then you can build on that. But always a combination between the languages would be the best. Like not just try to approach a problem only by R, only by KDB. Take the best thing from R, which has some very good points, pass them to KDB, and let it just play with it and process it.
Okay. One quick question as well, which is on this topic of plugins. Mm-hmm. Are plugins available for the free 32-bit version as well, or is?
Yes.
Okay.
Yeah, definitely. Only some of the plugins, depending on the developer and depending on the third vendor, for example, are not open source. There are also plugins which are open source, and you can download.
Like a community, for example. And
yeah. Or even from some of the people working in the banks.
Okay.
Also, people working in the banks have provided a lot of open source code for that.
Cool.
So yeah, you can find almost every single plugin open source and play around and download. The 32-bit version has absolutely no difference from the 64, only the ability on how much data processed and the usage. It's for big companies and some academic institutions might also need for their research the 64-bit. But in general, there are other people that are doing a kind of parallel 32-bit installation, which is also working well. It needs some research on how to put everything, and that would require some knowledge before, but it would be a very good solution. But as I said, as now people and other companies are trying to get in that area, the sales are trying to adopt on that and give more options.
Super, thanks. So, about the packages. So actually we're talking about for something similar with R or Python, we're talking for external libraries which can be imported.
Yes. Yes, exactly. You can just load the same way I showed with the file, with the database, with just the /l.
You load the...
Exactly, you load inside the library, or you load an external file. The same way, or also with other ways, you can import CSV files, you can import Excel files, you can import every single type JSONs. For everything, there is a way to import inside.
This KDB Studio you told us previously, is it by KEX or is it by third party?
No, it's by, I think it was by a developer, or just a single developer. Because, you know, for the first 15 years, there were no basic teams that were working on that. Only some guys, very good, high knowledge, working in the banks, very high positions. They were working a lot with KDB. So in their free time, they were just developing APIs, developing libraries, and some of them also developed the graphical user interface for them, but also gave it for free. So you can just Google and download it. It's very easy to install and easy to connect with KDB on the terminal and see both sides.
Give us an example of, for example, 2 or 3 maybe hidden databases, and are they also attached to 2 or 3 or one, let's say, real-time database?
You mean that?
And what would I need 2?
You mean 2 database, 2 32-bit versions?
Yeah.
For getting, because we saw earlier that the 32-bit has some limitations. So you can.
Because you mentioned that we might need to have a place where we would need to have 2 hidden databases and one in real time or custom.
The
real-time historical.
The real-time and historical database. Yeah, sorry. That also depends on the nature of the data. That's again for the banks only, not for other organizations. Because in the banks, the nature of the data can be different. As I said, in the first years, they were using only for trading. The latest years, they are using a lot of monitoring and analytics. So they should have a different RDB for the trading and a different RDB for the analytics and monitoring, because it's also very different the need for one and the other. That's why. And to just divide the resources on both sides.
So when you install KDB, it will automatically create 2 databases, an RDB and a KDB and an XDB?
No. That when you install KDB, you just have the Q terminal, and you just start to create your database yourself, whatever you want. Or there are some scripts, like this one that I showed you earlier. It was a standard script that is creating that database, and I used it as a demo here. But you can then, in your installation, have your database. And actually, when we are talking about RDB and HDB, we are talking for organizations that are getting real-time data, let's say the whole day or many times per day. Otherwise, there is no point if you just have your database with some records to have this KDB tick system. This is just for this kind of banks where they get the data, and at the end of the day, they have so much data that they can't really keep it in memory, which is the strong point of the language, but they need to write it on disk at the end of the day. So next day, everything that is coming is going again inside the RDB. In cases, let's say that we want to maintain a database with 7 million or 17 million records. There's no need to have an RDB, HDB system. You just do your inserts or maintaining your database the way you want, adding the fields or doing anything. So the RDB structure and ADB structure is only for that kind of feeding, keeping in the ticker plant, passing in the RDB, and final point at the end of the day, copy everything in the FTP, deleting everything from RDB. That's only for that case.
The way you say that this database is going to be in RDB, so it's going to be kept in memory.
Yes.
You did when you start the database, or like
in the beginning of the day, there is a process that starts the ticker plant, which imagine that every morning, let's say at 9, when the exchange opens, the first feeds are coming. So there's a process starting the ticker plant, and this ticker plant, every single data that is getting is written in the log file, and at the same time in batches or just single inserts, it's writing everything in the RDB. RDB is getting full the whole day. So it's getting data from the morning at 9 until 5:20, let's say. So at 5:20, when exchange is closed, the ticker plant is cleared, the log is kept for some more time, just in case something happens. And the RDB, there is a process that takes every single record from the RDB, writes that data to the HDB on disk, and then deleting everything from the RDB. That's the mechanism.
I assume that if you want to do some similar thing, like processing data from a time series of data from a financial institution, you have to make the same setup.
You have to do the same setup, and there are standard ways
So
to do
is
that setup.
the ticket plant part of the KDB installation and all this?
You won't need the ticker plant. The ticker plant is just for as an extra measure of keeping safe the bank data. But even with the RDB, things are working fine. It's just a medium between the RDB and the users to keep the RDB safe, especially for the banks. But even for ticker plant, there is specific code, and it is available in the site as well, that you can download and adopt it in your use case, change anything you want, reduce some values, whatever. And you can also use specific scripts to create your HTTP, your RTP, and the way they react. Everything is there. Obviously, they will need maybe a lot of configuration in the beginning, especially if you have a different use case, but everything is there, and you can approach that in that way. So,
yes, questions. One is the major platforms and UX software and so on. Are they nowadays interoperability? They have the interoperability with those systems? Because
yes.
As far as I know, Sophie's use Oracle, for example.
Sophie's use Oracle, exactly, but Sophie's has many fixing processes, let's say at the end of the night, that takes all results from KDB. So the way in our bank is working, for example, with Sophie's, because it's a good example. In our bank, the whole day we get data from Reuters. This data, we are subscribed to Reuters, and we get the data from Reuters. So the whole data is stored in KDB during the day. In the night, when everything has finished and the exchanges are closed, the Sophie's processes are coming to specific fields. Let's say the last, the close. So they take that, they store in the Oracle database, which is the Sophie's database, and this is used next morning for the trading and for all the analysis as the close price for that instrument. For Murex, it's exactly the same. They have many ways of communicating, and even better with Calypso. So they have a lot of APIs and connections between KDB and Calypso to provide support for that.
So you need the streaming with KDB, and whatever is very essential in terms of streaming goes to the standard library.
Exactly. That's a perfect use case. That's a perfect example, I think. Like you do the whole processing all day, and at the end, or whenever you don't need it, it can be not at the end, but even during the day. Let's say 1 or 2 times during the day, one before noon, keeping everything, storing everything, all the close prices in Sophis, and go ahead. Or even you might need different snapshots for other kinds of instruments like indices or futures. So again, you can kick the processes at some time for those indices, and another time go in the KDB, take the data for only the futures. Again, you can play around with different ways, but yeah, the communication is perfect.
Another one regarding the language. What kind of language is this written in Q itself, or is it you need something else? I was not there in the first 10 minutes, so can you mention if it's a included language or?
It is a functional programming language. Q is the programming language. Actually, Q in KDB is exactly the same thing. Don't think it as something different. We just use the Q name for the programming language. So whatever you type in the terminal or writing your functions, in KDB is called the database in general. But we can't really divide them because you saw that they are just one thing integrated. You can write your functions which are applied on the results from KDB, similar to what we said earlier about the 5 minutes delay, for example, to get the correlation. Things like that. That's why it's one thing, Q in KDB.
Is the language itself, is it written in Q or some other language mimic this one?
No, it's Q, and it was based on K, but it's Q, just Q.
Did you choose the name because it's a previous letter in the alphabet from R?
I'm not sure. Maybe. I'm not sure about that. No more? Yep.
I would just about how does that compare to other time series databases, like it used to be, like OpenTCD. There are other time series databases, open source ones.
Like which, can you repeat the names?
Yes, it used to be the one that is available these 2 years, the last 2 years. OpenTCD, which is based on Cassandra.
To be fair, I haven't heard of them, and these 3 years we haven't any project in the banks working with them, so I can't really tell you any opinion whether it's faster or not, based on what they are working with. And in the banks, especially the big banks, Morgan Stanley, they have a lot of research projects, not the European banks. The American banks have a lot of research projects, and in those projects they use a lot of different databases and languages. So there, if there was something, I should have heard that. I didn't see anywhere, so that's the only point that I can say, that probably it's not that fast or not that easy, scalable or anything, but I can't really tell you for sure on that, as I haven't worked at all.
So it doesn't have corporate support yet.
That's also a very good point, and especially for industry, this is very, very important.
And another question is about the data compression. Because we know that the corner databases are very good candidates for compression because of the redundancy, the data that's stored the same column. So that offers any compression.
There are some ways, there are some functions. I can show you if we open internet later. In the reference page of the codekx.com, if you go in the reference page, there are some .q and some other letters which are functions that are doing exactly these kind of things, different kinds of compression and other that kind of tasks and jobs that help with that, and they can get some parameters depending on what you want to have as a result. So yeah, everything is provided as a standard solution, and some of them can also take customized queries by you or customized parameters by you, so you make it the way you want.
What's the licensing model for commercial use?
For non-commercial use?
No, for commercial use.
The cost?
Yeah.
The cost, I'm not the best person to talk about.
Okay.
Probably a mail to the sales would be great, or I can give you some details to get in contact with. And the important thing here is why I can't really say is normally a big bank will have a license for many years, and this license will be a couple of hundreds of thousands of dollars, euros, whatever. A startup or a small company won't need the same amount of course, licenses, everything. So that should normally be adapted in that way. But until these years, there weren't any cases where there were very small companies or startups or these kind of things. And this is something that changes. So they are adapting to that. And that's why they ask for people to go to them. And depending on the case, I think every case is judged in a different way. Depending on the case, they provide the cost. That's why I can't say. That's all.
Okay.
Thank you very, very, very much.
So, Christoph, thank you very much. Thank you very much to KX for sponsoring and completely organizing this event, taking care of everything for us. There are beers downstairs. I want to say just two or three quick words. I want to send a really big and massive thank you to Corne, who have been with us from the beginning. Corne, our partners, Corne.gr, are taking care of the audio visual, the live stream, and they're going to be helping us to create our website. At the moment, it's just hosting the live stream. But it's going to have the content at last, I hope, and we're going to sit down and actually make all the content to bring it out to you folks. I do promise I will put out all the content from all the meetups we've had so far, including this one, on the website. Stratus is going to push me for this. And I also want to say a big thank you to those of us watching from the live stream. And finally, those of you who would like to take part in the competition that KX is running, what you mentioned in the beginning, please come up here and Christos will record your name. We'll run this raffle. The rest of you, join me downstairs for drinks. Thank you very much. Thank you for coming.
Thanks a lot for your time. So anyone that wants to be in the lottery, just come to